Postulates of kinetic theory of gases. The kinetic theory of gases explains the behavior of gases by considering them as a collection of many small particles, atoms or molecules, in constant motion. It is based on several fundamental postulates. 1. Gas molecules are in continuous random motion. The molecules of a gas move in all directions at different speeds. Their motion is random, meaning they collide with each other and the walls of the container. 2. Molecules are point masses. The size of the gas molecules is negligible compared to the distances between them. They are considered as tiny, hard spheres with no volume of their own. 3. Collisions between molecules are perfectly elastic. When gas molecules collide with each other or with the walls of the container, there is no net loss of kinetic energy. The energy may be redistributed among the colliding molecules, but the total kinetic energy remains constant. 4. There are no intermolecular forces. Gas molecules do not attract or repel each other, except during collisions. This assumption holds true for an ideal gas, but may not be perfect for real gases at high pressures and low temperatures. 5. Pressure is due to molecular collisions. The pressure of a gas results from the collisions of gas molecules with the walls of the container. Each collision exerts a tiny force, and the sum of all these forces leads to the observed pressure. 6. The average kinetic energy is proportional to temperature. The kinetic energy of gas molecules depends only on temperature. The mean kinetic energy, EK, of a gas molecule is given by EK equals frac 32 kBT, where KB is the Boltzmann constant, and T is the absolute temperature. Higher temperature means greater molecular speed and vice versa. Collision number Z in kinetic theory of gases. Definition. The collision number is the average number of collisions that a gas molecule undergoes per unit time. It is an important concept in understanding the behavior of gases at the molecular level. There are different types of collision frequencies. 1. Self-collision frequency, Z1, the number of times a single gas molecule collides with other gas molecules per unit time. 2. Total collision frequency, Z2, the total number of molecular collisions occurring in a unit volume of gas per unit time. This is given by the equation. Z2 equals frac 1, 2, NV text AVG sigma, where N equals number of molecules per unit volume, V text AVG equals average speed of gas molecules, sigma equals collision cross-section, effective area for collision. 3. Mean free path, lambda, and collision frequency. The mean free path is the average distance a molecule travels between successive collisions. It is given by lambda equals frac 1 squirt 2n sigma, where n is the number density of molecules. The collision frequency, z, is related to the mean free path as z equals frac v text avg, lambda. This gives the number of collisions per second for a given molecule. Significance of collision number determines reaction rates in gases, as chemical reactions depend on the frequency of molecular collisions. Helps in calculating transport properties like viscosity, thermal conductivity, and diffusion. Important in understanding gas laws and deviations from ideal behavior. Would you like a numerical example to illustrate collision number calculations? 10 multiple choice questions, MCQs, on the kinetic theory of gases and collision number. 1. Which of the following is not a postulate of the kinetic theory of gases? A. Gas molecules are in constant random motion. B. The collisions between molecules are inelastic. C. Gas molecules do not exert attractive or repulsive forces on each other. D. The average kinetic energy of gas molecules is proportional to temperature. Answer. B. The collisions between molecules are inelastic. 2. According to the kinetic theory, gas pressure is caused by A. The weight of the gas molecules. B. The attractive forces between molecules. C. The collisions of gas molecules with the walls of the container. D. The repulsion between gas molecules. Answer. C. The collisions of gas molecules with the walls of the container. 3. Which of the following parameters affects the mean free path of a gas molecule? A. Temperature and molecular weight. B. Molecular size and number density. C. Pressure and volume. D. Temperature and pressure. B. Molecular size and number density. 4. The number of molecular collisions per unit volume per unit time is called A. Collision frequency. B, mean free path. C, average kinetic energy. D, mean square velocity. Collision frequency. Half 5. If the temperature of an ideal gas is doubled in Kelvin, the average kinetic energy of the gas molecules will A, remain the same, B, double, C, become half, D, increase by a factor of 4. Answer B, double. 6. What happens to the collision frequency of gas molecules when the pressure increases at constant temperature? A, it increases, B, it decreases, C, it remains the same, D, it becomes 0. A, it increases. 7. The mean free path of a gas molecule is given by the formula A lambda frac 1 n sigma, B lambda equal frac kt, C lambda equal frac 2 n sigma, D lambda frac rt lambda if frac 1 2 n sigma. 8. The unit of the collision number is A text quinmiteshwi, D text j, D text x to 2 and minus 1. 9. The kinetic energy of a gas molecule is directly proportional to which of the following? A, pressure, B, temperature, C, volume, D, density. B, temperature. 10. Which of the following factors does not affect the collision number of gas molecules? A, molecular diameter, B, temperature, C, volume of the container, D, chemical composition of the container walls. D, chemical composition of the container walls. Would you like an explanation for any of these answers?